This is Algebra 2, Unit 9, Lesson 6, and today we're going to learn how to find x and y intercepts of rational functions. An x-intercept is the point where a graph crosses the x-axis. That's going to occur when your ordered pair has a value, an x value, and then the y coordinate is 0. So in order to find x-intercepts when we're given a rational equation, what we're going to do is we're going to set y equal to 0. Or if the function is an f of x, we would set f of x equal to 0. If you set y or f of x equal to 0, you will be able to find your x-intercepts. The y-intercept is the point where the graph crosses the y-axis. To find the y-intercept, this is always very simple to do. All you have to do is plug 0 in for your x values in the equation. So an ordered pair that crosses the y-intercept has an x value of 0 and then a y value that is some other number, unless it crosses at the origin, of course. So if I want to find my y-intercepts, I'm going to set x equal to 0. So if you think about this, to find your intercepts, if you're looking for the x-intercept, you're going to set y equal to 0. If you're looking for your y-intercept, you're going to set x equal to 0. So you set the opposite variable equal to 0 in your rational equation to find your intercepts. So here's my first example. They're asking us to find the x and y intercepts of this function. And normally we're going to use x and y intercepts when we're graphing. So that's what we're leading up to. In the last lesson, we learned how to find the horizontal, vertical asymptotes, and holes. In this section, we're learning how to find the x and y intercepts. These are all things that you need to know how to do in order to graph a rational function. So that's what our next section will be, putting all the information together and graphing. So if I'm looking at this one and I want to find my x-intercepts, well, to find my x-intercept, remember, you set y equal to 0. So I'm going to set this function equal to 0. Now, when a function has a denominator, setting the function equal to 0 just means that when I have a denominator like this, I can multiply that denominator over to the other side and it's going to go away. So if I multiply both sides by the denominator, I then have 0 equals 20x plus 12. And then I'm going to solve that. So negative 12 divided by 20 would equal x, and then I just have to simplify. That would be negative 3/5 for my x-intercept. So your x and y-intercepts are not always going to be nice whole numbers. Sometimes they're going to be fractions, and that's okay. You would just estimate where that would go on your graph when you're graphing it. But the good news is we'll use Desmos to do most of our graphs, so you won't even have to estimate it. The computer will do that for you. And then, so we found the x-intercepts. To find the y-intercept, remember we set x equal to 0. So everywhere that I have an x, and I'm going to rewrite the f of x as a y, everywhere that I have an x in this equation, I'm going to plug 0 in. So if I plug 0 in here, I just get 12 on the top. If I plug 0 in here, I get negative 48 on the bottom. So that means my y-intercept is at negative 1/4. Okay, so that means this graph would cross the y-axis at negative 1/4. It would cross the x-axis at negative 3/5. Now, when they ask you to find the intercepts, they're asking you to find the ordered pairs. So if this is the y-intercept, that would be the ordered pair 0, negative 1/4. Remember, we plugged 0 in for x. This ordered pair would be negative 3/5, 0, because remember, we plugged 0 in for y there. So those are our x and y intercepts. So I have two more examples up here. We're going to do the same thing. We're going to find the x and y intercepts. For this one, if I find the x-intercept, I'm going to plug 0 in for y. I'm going to multiply the denominator over. That leaves me with 0 equals 4x plus 8. And then if I simplify that, I have negative 8 divided by 4 is a negative 2. So my x-intercept is negative 2, 0. For my y-intercept, I'm going to plug 0 in for all my x values. So 0 plus 8 gives me 8. 0 minus 8 gives me negative 8. So my y-intercept will be at negative 1, which is the ordered pair 0, negative 1. In the next one, if I find the x-intercept, remember I'm setting the y equal to 0. And then if I multiply that over, this one is going to make me factor to be able to find the x-intercepts. And remember, x-intercepts are the same thing as roots. They're the same thing as solutions, and they're the same thing as the zeros. So this one is just going to happen to have more than one root. And we've talked about that before. We have more than one x-intercept in a lot of different graphs, and this is no exception to the rule. So to find the x-intercept here, since this is a quadratic, we're going to factor. Factors of 10 that subtract to give you 3 would be 5 and 2. It's a minus 5 and a plus 2. That gives me 2 x-intercept. X equals 5 and x equals negative 2. And those ordered pairs would be 5, 0 and negative 2, 0. If you're working in Delta Math and you're doing problems like this and you have more than one answer, remember if you click the little plus button, that will allow you to add another answer into there. So if they just give you one box for an answer, if you just hit the plus box or the plus button, it'll create another box for you to enter your second answer. To find the y-intercept, I'm going to set the x's equal to 0. 0 minus 10 would give me a negative 10. 0 plus 8 gives me an 8. So y equals negative 5/4 for my y-intercept, and that as an ordered pair is 0, negative 5/4. So we found all of the x and the y-intercepts there. So here's one more example. I want you to go ahead and pause the video, see if you can get the answers to this, and then we'll go over the answers afterwards. So here are your answers for this one. If I let y equal 0, the denominator cancels out, and that leaves me with the 2x squared minus 1 equals 0. When I solve that, I end up with 1/2 equals x squared, and then I take the square root of both sides. When I take the square root, remember when you put the square root in, you have to have a plus minus. So I ended up with x equals plus minus 1 over square root of 2, and then I rationalized the denominator to get plus or minus square root of 2 over 2. So the two ordered pairs for that would be square root of 2 over 2, comma 0, and then negative square root of 2 over 2, comma 0. So those are my two ordered pairs for the x-intercepts. And then in the next one, this is kind of a special case here. When we set x equal to 0 here, on the top we're going to end up with a negative 1, and on the bottom, if you notice, we end up with 0. And remember, you can't divide by 0. So if you have division by 0, that's going to be an undefined. So our y-intercept is undefined. So we don't have a y-intercept there. And basically what that means is, if you think back to what we learned in the last lesson, where would you have your vertical asymptotes? If we set the denominator equal to 0, isn't that going to be equal to 0? So we have a vertical asymptote at 0. So the line doesn't cross the vertical asymptote. So that's why we don't have a y-intercept. The y-axis is a vertical asymptote. So it's not going to have an intercept.